Привет, Никола Франкель.
Hi, Nicholas. Hi, Nicholas Frankel.
Hi.
Расскажи, пожалуйста, пару слов о себе.
Please say a couple of words about yourself, what your experience is and why you came to IT.
Меня зовут Никола Франкел. Я учу русский язык чуть-чуть, but I will switch to English because it's very hard for me. Actually, I don't have any upbringing. I don't have any formal education in IT. I studied architecture and civil engineering, but I always was fascinated by code and how you create software and stuff like that. So as soon as I went out of school, I tried to find an internship in like software company. And then for like a long time, I worked as a developer, as an architect, as a team lead, well, different technical roles. And since 2 years, I'm a developer advocate. So I don't do projects anymore. I'm just trying to talk to people and try to like interest them in some of the stuff I discovered by myself.
Еще я знаю, что ты преподаешь. Почему ты стал...
I know that you teach. So why did you decide to become a teacher?
That's a good question. This year, I stopped being a teacher. Actually, my contract was not renewed. I think that's... I love to learn. I really like to learn lots, but I also like to teach. I mean, for me, it's the two legs of the same coin, the two faces of the same coin. Like you receive something and you need to give it back somehow. So yeah, for me, it was never a question, why should I become a teacher? It was just like fun. Like I do most of the things, it's for fun. It brings me a lot of joy to like when I see interest in people, when I see they're interested in learning, and I want to help them like on their way so that it's easier for them. Because learning software, learning to code is not easy. You make a lot of mistakes. I mean, I did a lot of mistakes. I still do a lot of mistakes. But you can learn by yourself by making mistakes, or you can learn from mistakes made by others. And that's what I try to tell them. Hey, I did this mistake. Probably you shouldn't do it.
Спасибо большое, Никола. Давай переходить к докладу.
Пожалуйста,
Yes,
спасибо
Nicola,
большое.
let's move to the presentation.
Ну, я понял. So thanks for having me in Novosibirsk, even if it's remote. I hope that sometime I will be able to see you on site. Well, I've already talked about myself. I'm a developer advocate now, and I work for a company called Hazelcast. Perhaps you already have heard about Hazelcast. We have two products. Our first product is an in-memory data grid, and you can think about an in-memory data grid as distributed data structures. So instead of having your hash map inside your JVM, for example, and being bounded by this JVM, then you can replicate it and shard it over several different nodes. And our second product is called Hazelcast Jet, and it leverages IMDG to do in-memory stream processing. Today, I won't talk about neither of them. I will talk about zero downtime. And it seems that zero downtime has become the grail. And the question is, why do we do zero downtime? Why do we even try to achieve zero downtime? Well, the first people who are responsible for that are probably you and me. It's because it's super cool. Like you want to solve hard problems, and zero downtime is a hard problem, and we want to solve it. So between a company that works on zero downtime and that implements it and a company that doesn't, then probably cool engineers will want to move to a company that does it. The second reason is that users expect it. Like I remember when I started working, when we needed to deploy our application to production, Well, we like put a static page on our front end load balancer, and we display this page saying, hey, sorry, we are back in a few minutes or a few hours or whatever. Then we deployed our stuff, and well, that was business as expected. But right now, if your parents or your grandmother, they use Facebook, they use Google, they use any of those tools, they have never seen such a page saying, hey, we are back in a few minutes. People that don't know about IT, that don't know about deployments, that don't know about this kind of stuff, and they just find it normal that the application is always on. And the final reason is that probably business has a huge incentive to have no downtime. Like imagine you're an e-commerce shop, and you tell your business, hey, sorry, folks, we need to like close the shop for a few hours. And in their mind, it translates like it's a loss of revenue, because if customers during that time frame wants to come to the shop and buy something, he will see this page and he will probably buy on another site. So for all those three reasons, you might want to consider to have zero downtime. And probably you might already do zero downtime, because at least the recipe is known since a few years. Like you have this deployment pattern called blue-green deployment. And so blue-green deployments means you have two completely similar environments. One is called the green ones and the other the blue one. And at some point, the green one is the production environment. You have like a router, it might be a hardware router, a software router, whatever. You have this router that forwards the traffic to the green environment, and everything works fine. And then meanwhile, you deploy the new version of your application on the blue environment. And then at the push of a button, you just direct the traffic to the blue environment. The blue environment becomes the new production environment. And meanwhile, you can deploy a new version on the green, and so on and so forth. Of course, there is some variation. For example, here you can see that in this option, we have two separate databases. But you can say, hey, but we will have a single database, so we don't need to migrate the data. So blue-green deployment for the win, end of the talk, that's fine. But actually, there are some issues with blue-green deployments. The first one is the routing latency. Here, I just like clicked the slide, and like instantly all users were redirected to the new environment, but it might take some time for the routing to take place. So you might have users that are directed to the green environment, whereas you said that, hey, they need to the blue, and it might take some time for every user to be directed to the new environment. Then what happened, I talked about like e-commerce shop. What happens if you have a cart on the green environment and you need to direct the users to blue environments? So there is this issue about what about the sessions? And finally, as I mentioned, the biggest hurdle in the data is in the database. So either you have two separate databases, and then you need to migrate instantly all the data from the green environment to the blue environment instantly, because you need the data as soon as possible. Or you keep the same database, but then it's an issue regarding, hey, what if you need to migrate the schema? So it's not as easy as it seems. And comes Kubernetes. And Kubernetes, as you know, Kubernetes saves the world. Kubernetes makes everything magical. So if you check talks about Kubernetes, they bring this rolling update principle. So you have 3 nodes with version 1.0, and Kubernetes with this rolling update principle will make it to the version 2.0 in a gradual way. And the YAML, because we not need to use YAML, adds this deployment resource, and then you have the strategy rolling update. And you see there are 2 types of parameters. The first one is a max surge, and the second one is a max unavailable. And the max surge is actually the number of extra pods that you are willing to create to do the rolling updates. and the max unavailable are the number of pods that you are willing to have lower than the number of replicas to do the rolling update. So let's have two simple examples to illustrate it. I have like 3 replicas, and I have configured it to have max unavailable 0 and max surge 1. During T0, the initial time, I have my 3 replicas of version 1.0. And because I have max unavailable 0, I cannot go down. I cannot go lower than 3, but I can go like 1 more. So I can create a new, or more specifically Kubernetes is allowed to create 1 more pod of the version 2.0. So it will like schedule this 1 more pod, and then it can remove and schedule one of the 1.0 pods to get back to 3 replicas. And then we do that the same again, and we do the same again until all of the replicas are of version 2.0. So in this scenario, we are willing to pay a bit more, probably because we are using the cloud, to have like an additional infrastructure and yeah, to have no downtime. On the opposite side, you can like lower your number of available pods. So here I have max unavailable 1 and max surge 0. So we keep the same hardware, we keep the same costs, and we accept to be down with a slightly lower number of pods at some time. So if during T1, for example, I receive a request, well, only 2 pods will be available to serve this request. But still, at the end of the period, we still all have our 3 pods that are of version 2.0. And of course, you can mix and match to be faster. So you can have max unavailable 1 or max surge 1. And then if we start from 3, you can remove 1 and then schedule 2 new ones. And then you can remove the 2 old ones and back to 3. So it depends on your aversion to risk. It depends on your resources. It depends how fast you want to move it. I mean, it's easy. Kubernetes make that easy. But there is an issue, is that applications, they don't start instantly. So Kubernetes needs to know about the application state. It needs for the pod to be ready before it sends requests to it. And I will be using Spring Boot because, as I mentioned, I'm a Spring Boot fan. It can be any stack, but Spring Boot makes it easy because it offers an out-of-the-box endpoint for that. And for that, it's called the health endpoint. And so we have this Kubernetes Spring Boot integration magic. It's just a puzzle. We say to Kubernetes, hey, just ping this endpoint, and this endpoint will tell you when it's ready. And then in Spring Boot, we have nothing to write. Actually, we just add dependency, and it will bring up this readiness endpoints, and then they can talk to each other. And when it's ready, Kubernetes will say, oh, this pod is ready to receive requests, and I can continue my rolling update. It could be the end of the talk, and in general, it is actually. But the problem is I didn't address the issues that I mentioned. And the issues that I mentioned is about the state. So if you only have computing nodes, it's super easy with Blue-Green, with Kubernetes, with anything. I mean, you can even do that, scripting that yourself. It's easy. And yeah, you might know about this comic that you can solve problem just by saying Kubernetes. Actually, in most cases on the internet, you can. The issue is still the same. The issue is the database. So if we do a rolling update, but now I put back the database into my architecture diagram, you can see that if we have version 2.0, and if we migrate the version of the schema to 2.0, well, the computing nodes, the application, which is still in 1.0, cannot understand the new schema. It doesn't work like that. So we break everything by just having these database nodes that needs to migrate the schema. Let's think a bit. What can we do? Well, we must say that, okay, in that case, what we can do is that the application version must be compatible. That's fine. So let's rework our stuff. And we say that we will first migrate all nodes to 2.0, and afterwards we migrate our schema to 2.0, and we have solved the problem. Well, probably yes, in most cases, but it never happens that you had to roll back a migration, right? Never happens because everything works fine on the first try. So if you want to roll back here, well, you are back to your usual problem. It doesn't work. It doesn't work. So again, it's still the state, it's still the database that is preventing us from having those nice rolling updates. So let's think further. What if we broke down one big incompatible change into a series of changes that are compatible side by side? So instead of having this big potato, we will just like slice the potato, and we can like move forward one step and get backward one step without issues. How does it translate into a real use case? As I mentioned, I was a developer. I was really always bad at designing like table models. So here I want to tell you about my experience. I have a single table. I designed a single table at the beginning of my application, and my application got successful because I'm a super good business owner. And now I need to evolve this schema into not a single table, but two tables with a PK-FK relationship. So this is my initial design. I have this person, and this person has an ID, a name, and address related stuff. And if you have been studying software or computer science, you know this is about design. In general, what you want is to have two different tables, one for the person and one for the address. And then you have this a primary key, foreign key relationship. I think it's a good use case. It's not too complex, but it's not trivial either. This is generally this kind of problem you will need to address. So, as I mentioned, I want to like decompose this change into a series of like one step forward and one step backward compatible changes. And for that, the first step, I will create the address table. And then my application will continue to use the person table as previously, but every time I do a change on the person, which contains address related fields, then I will somehow take the data from the person table into the address table. But I will keep the person table as the source of truth. So it still contains all my data. The second step is I will create, the address now becomes the source of truth. So as soon my application will use the address table, but somehow, some way, if I make change to the address table, the changes, they are mirrored into the person table. And now imagine I need to roll back. My person table will contain everything I need, which is exactly what I want. And after some point, then the address table will be like complete, and I will be able to do some cleanup and to stop copying the data. So that's my idea. And I know this is a DevOps conference, but I'm sorry, in DevOps there is dev. So I need to get into some specifics about the development side of things, because you cannot achieve zero downtime without involving only the ops part or the dev part. You also need to involve the organization, the project manager, and so on and so forth. So perhaps you know about Spring Boot. I mean, if you have been involved in the Java ecosystem, you probably have heard about it. And by default, Spring Boot tries to make everything like easy for you. So there are a lot of configuration issues that you don't need to delve into because it's convention over configuration. And for example, if you use a framework called Hibernate, which is the default, like the schema will be created out for you. Now imagine we have those like nodes of Spring Boot application and we deploy the version 2.0 and we have a single database. And of course, Spring Boot will try to update the schema and we will run back into the first issue that as soon as you deploy one node, then the database will become 2.0 and the old nodes, they will crash. They won't be able to use it. So we want to disable that. That's the first thing. And we will use something that is integrated with Spring Boot called Flyway. You can use Liquibase. Again, those two terms, you might have heard about them. They are probably what you should use even right now, even if you don't do the zero downtime. And Flyway is basically translate into the version control for your database. Like how many times do you use a database and if something crashes, you have no way of recreating the schema because every time you needed to do a change, you sent a script to the database administrator. He executed the script, and then whatever happens, it worked. So nobody cared about it. But sometimes you need to do some migrations, and in that case, you will be very happy to keep all your scripts. And then you can send all the scripts in a specific engine, and all the scripts, they will be executed in the correct order. And that's exactly what Flyway does. And again, there is another competitor called Liquibase. I'm just using Flyway because I'm used to it, but I have nothing against Liquibase. The concept of Flyway is based on something called a migration. And migration is just a plain SQL script. The good thing is that in the name of the SQL script, you need to put the version. And so because you put the version, there is a certain pattern to follow. Then you can send a bunch of scripts to Flyway. It will order them and it will execute them in order. And once a script has been executed, Flyway records it in the specific dedicated proprietary table that it creates for itself. And if a script has already been executed, then you won't execute it a second time. So again, for our pods, that means that if you have different pods and you deploy a pod which is of the same version, it will try to execute the script, but the script will already have been executed, so it will be a no-op operation. In order to run the migration, you have several ways to do that. The first, like Flyway, comes with a command line interface. You can create a job. You can use the init container of Kubernetes, but actually what we will be using is directly the integration with Spring Boot, because then it will be completely automated. So if you have your Flyway scripts, you store them in the DB migrations folder. And when the application starts, then it will try to apply those migrations. And as I mentioned, if the migration has already been applied into the central database, then it will be no operation. Well, I've talked a lot, and I believe now it's time for some demo. So I will try to do that for you. Can you still see my screen? Because I need to show some code, and I need to be sure that it works as expected. If you see my screen, can I get some feedback that you see my screen? Simple DA will be enough.
Yeah, we can see it. We see your screen.
At least now. Thanks. So I've created a Spring Boot application. It's not a very developed application. It's just simple Spring Boot with a screen, and there is this controller, and this controller has two mappings. The first one is I get all the entities from the database, and the second is I can create one entity. I'm using Spring Data GPA, which means I don't need to create the queries or the SQL by myself. Everything will be handled for me. I'm using Kotlin because I'm a Kotlin fanboy also, but of course you can do the same in Java or in any JVM language. there is one specific stuff. I've created something called a context that I will inject. And this context gives me two information and the version of the application, because I want to prove it to you that it works. And I will be using it also to get the name of the pod. So let's try it only like self-contained. So I will like run this application. And now it compiles everything, and normally everything should work fine because I didn't change anything since last time. And here I go on this, and here I have this like wonderful application, and everything has been working as expected. As I mentioned, I have already created this DB migration, and the DB migration creates the table. So I have the table that is completely created. And just to be sure, I insert a new person, John Doe, Linkin Park, whatever, and it's here. And here I can create a new one saying okay. Great. Yes, it works as expected. Everything is fine. This is the local version, so it's a no-brainer. Sorry. So now what I want to do is I want to containerize this application, and I want to deploy it on my friend Kubernetes. So I have already created everything out of the box because I don't want to run into the demo syndrome. The first thing, how do I create the container? If you are using a Java application, I would suggest you use Jib. So basically, Jib will create a Docker image and push it either to your image registry or to your local Docker daemon. Here, every time I compile, I will push the image to the local Docker daemon, and that's done. And now I have my deployment. So here I've created H2 deployments because I will be using H2. It's very stupid to do for real application, but here it will help me. So I've created an alias. K is kubectl, and I will apply this database YAML. K get pods watch. Yes, it's already running. That's fine. So I can check that everything works out as expected. So it's this one. Yes. And here I already am able to get into the console. And if I remember the name and I don't remember the name, I need to say that it's zero downtime. It's localhost zero downtime. Zero downtime. Nope, it's not. I forgot the. Yes, this one. So here I have this H2 console that gives me an insight into my application. Nothing has been done yet. What I will do, I have this deployment is more interesting. I've created the namespace. I assume you know that you should always use namespace. I've created a service so that I can be able to interact with the deployed application. And I have this deployment of 3 replicas. And as you can see, I have a max surge 0, max unavailable 1. So I will go 1 replica lower. And I have set the actuator health readiness endpoint, and it will be using this database, H2 database that I have used as a server. So now I will deploy it. K apply f application.yaml. K get pods watch. So, sorry, the first pod, for whatever reason, that will be started will actually be able to create the schema. And if we go on back here, if we refresh here, now that would be good if we created the schema. It's taking a bit of time. I don't know what happens. And now that's the demo syndrome. So I will try to get into the application and hope that I didn't break anything. Why doesn't he show me the schema? If I do that and I connect again, it doesn't show me any changes, which is bad. Ah, I know why. I should be using 0 downtime. Yes, sorry about that. So here, as you can see, like Flyway created this table for itself, and he passed the first script, which is the script that I showed you that creates the table inserts one entity. And of course, because I've created this one entity, it is here. And if I go to my application, then you can see the pod I'm running on, and you can see that it's a version 1.0. So I can create a new entity. And of course, you can see it here. Nothing mind-blowing. It works as expected. Now what I will be doing, I will be going to create this address table and address entity. So I create this new script, which creates the address table. And I will do something sneaky. It requires a bit of understanding of the underlying Spring Boot model. So what I will be doing is I've created this new address entity. And with Kotlin, I will create a synthetic field. And most importantly, I'm not using any trigger. I'm using code. So every time there will be a change on the entity, and here it's the create, because I don't do updates, I do only creation, then I will also save the address. And of course, it depends how you want to address it. You can create triggers, you can have some sort of change data capture or whatever. Here, I chose to use a code to do that. So every time there will be a change in this entity, then I will save the address. So now I get to deploy the new one, and I can apply the new one. The application has been changed to be 2.1. And now I want to show you that, well, it won't disturb the stuff. And I will refresh the application. And it might take some time, unfortunately. But here you must keep your eyes on this. So at some point it will change. Yes. And here you see that I was redirected to another pod, but still on the version 1.0, which can happen, and it's not an issue. And of course, it's always the last one that gets killed. Yes. And as you can see transparently, I was redirected now to a new version of the pods. And we can check here. I can refresh. You can see this address table has been created. Why? Because the Flyway has been applied. This add address table script has been applied. And now we can see that this address table, well, is empty because we didn't create any data. What we could have done is we could have already copied the data. But if we roll back at this point, then we just would have copied data without any benefit. So let's keep it that way. However, now I will create a new one. I will say I'm Clark Kent, and I live in far away. All. And here, I still have everything into my main table, but I've copied the changes to this address table. Still okay. That was good And now the next step is to make the application use the address table as a source of truth and copy the data from the address table to the person table. So let's do that. So I've incremented it. I have created this new script. And in this new script, I actually do migrate the data. So this is a H2 specific stuff. I'm not a SQL fan. I just remember that it just copy everything just to be sure. And then my model now is different. It says, hey, if the entity is an address, then like save the address also into the person table. So I changed my way to look at it. And as you can see, my model now has this join between the person and the address. Now I have created the relationship for sure in the code. And now I will update and I will deploy this new pod. And again, refresh, refresh, refresh. So same things as before. The first pod that gets deployed will try to execute the script. So we must check here, for example. It has executed the script. That's cool. And we again refresh. Why do I refresh? To prove you that there is zero downtime. If there is no, if I don't do that, then you can tell me that I'm saying crap, which I don't want. Here, I am on version 2.2, and it still works. I still have all my data, and I want to say Diana Rings, and it's London. It still works. And if I check on the data, I've everything that got migrated into the address table. And of course, I've copied everything into the person table. Now, I just want to prove you that now I can roll back one step and still everything will be fine, because the next step is to do cleanup, and cleanup is not super interesting. So I will get back to my previous 2.1. No, not here. Here. So I want to do some rollback. And I will apply again. And now no script needs to be written here. I've passed everything, so no script needs to be written. It's purely Kubernetes related. And at some point, you will see that there will be a 2.1. Now, of course, you must find yes. So the pod I was on was 2.2. I was redirected to a 2.21, not to a 2.1. So I still need to keep working and refreshing and whatevering. Please do that for me. Yes, and I'm on 2.1, and the application still works. I can create, I don't know, Hello World, which sits in Saint-Julien. This is the place where I'm living, and it still works as expected. So let's get back to the slides. What I showed you in this talk is that it's completely possible to do zero downtime. However, you shouldn't believe most talks on the internet that tell you, hey, just use deployment and everything will be fine. It's far for free. It actually has a huge impact. It has an impact on not only the developers, it has an impact on how you deploy the application, and it has an impact on how you make your commits, because you need to not to have one huge commit, but you need to have like baby steps commits. And here I showed you how to do it with one feature. Now imagine you have multiple features and you have all those baby steps. So in that case, handling deployments requires some planning and some project or program manager who handle all the organization between all the changes. So thanks for your attention. You can read my blog. You can, of course, follow me on Twitter. If you want to know more about Hazelcast, I will be happy to help you, but you can already go check the site. If you want to use the code, because the code I showed you is actually on GitHub, then I encourage you to clone it, to like store it or whatever, or to improve it. And if you want to join the conversation about Hazelcast, we have a Slack channel, so please join our Slack. It's all about distributed systems and sharding and replication, and I mean a lot of hard stuff that Russian developers, they love. So perhaps now there are some questions, and I will be happy to answer them.
Thanks, Nicola. Thanks a lot for the presentation. We have some questions like, do we have a possibility to validate the migration before running it on production?
I believe that you should use. I believe you should use the same validations that you used before production, before doing the zero downtime. Like you probably have like a testing environment, or I don't know, a pre-production environment, and I will like advise you not to deploy to production. Like, how can I say? How do I say that in Russian? Хуёво, that's probably the term I was searching for, but to like test and check everything before. So use the same methods that you used before.
And one more question. What do we do with the changes that block the table in the database?
I'm not sure I understand the question. The thing, I will try to answer, and then you can tell me if I answer the question. If not, then please detail it. The thing is, we had this one big change, and we sliced it into baby steps. So every time you need to like do one baby step, validate that everything works as expected, and if not, you roll back. Now the problem is if you make two baby steps, you cannot go back 2 baby steps back. Ни обратно не можно. It doesn't work like that. It's only one baby step compatibility, so you can go forward 1 step and go backward 1 step. At some point, if you see that it doesn't produce the results that you wanted, you need to stop, roll back, and, well, handle the problem. It's not free, as I mentioned. Это не бесплатно. Это жизнь, детка.